Problem 11. A dielectric material is to fill the space in a capacitor. Initially, with only air in place, the capacitance is 8.0 picofarad. With the dielectric material in place, the capacitor should store 3.2 microjoule at a maximum potential difference of 350.8 volt. Here we have two questions. The first question is, what dielectric constant is required? And the second question is, of the material in given table, which material should be used? So actually, in this question, the first part, we have to find the dielectric constant of that material. And once you got the answer for the dielectric constant, you have to check the value with the given table. So your value should be matched with one of the material. So you have to mention what is that material. So that should be your answer for the second question. So let's start with the first part. So here we already know the capacitors with dielectric, and also we know the equation for the capacitor without dielectric. So that means the value for the capacitors in air, which is given the value of 8 picofarad, right? So 8 picofarad for air between the two plates. That's the reason they mention between the two plates the air is placed. So that value is already given here as 8 picofarad. So pico stands for 10 to the power of minus 12. So we have to write this number as 8 multiply 10 power minus 12 farad. Now we have to find the dielectric. So for that we have to use the formula. So the formula we already studied. What's the formula? Because here we are going to use the energy. Because why? If you see the question, they give the value of the energy stored in the capacitor is 3.2 microjoule. So that means we have to take the formula for the energy stored in the capacitor. As we know the formula for the energy stored capacitor, we know U, which is equal to half multiplied by the capacitors multiplied by the potential square. So here they mention you are going to find the dielectric. That means we can just multiply this term with K, multiply with half, multiply by C. So here C is nothing but the capacitance for air. Clear? Multiply by the potential square. The potential value is already given in the question, which is 350.8 volt. And by using, and also they mention how much energy you stored as a maximum. The energy stored as maximum here is 3.2 microjoule. That means micro means 10 to the power of minus 6. So by using this relation, and I am going to rearrange this equation in terms of K. So if you rearrange this equation in terms of K, what you will get? K equal to 2 multiplied by the energy stored divided by the capacitance in air multiplied by the potential square. Now what I am going to do, I am going to substitute the value in this given equation. So 2 multiplied by the energy stored here is 3.2 microfarad. So 3.2 multiplied 10 power minus 6 divided by the capacitors in air is 8 picofarad. So 8 multiply 10 power minus 12 multiplied by the maximum potential you said is 350.8 volt. So I have to write 350.8 it's a square, right? So we have to square this number. So let's see what's the value of the dielectric we are going to get. So I can just move a little bit more. So now I have to calculate to find the value of K. So let's see what should be the answer for this. 2 multiply 3.2 multiply 10 power minus 6 divide by 8 multiply 10 power minus 12 multiply 350.8 the whole square. I got the answer here as 6.5. So the K value here I got is 6.5. Now I have to compare this value in the given chart. So the value of K here we got is 6.5. So let's see the table. Where is the value of 6.5? Yeah, here we have 6.5, right? So this 6.5 is for porcelain, right? So that means the material we used in between the capacitor is porcelain material. Why? Because the answer in the first part we got 6.5. So how you can answer for the second part? In second part, the value K, which is equal to 6.5, in chart we got the value of 6.5, which is related with the material porcelain. Porcelain. So this material we used in the capacitor. So this is the answer for this question. And one more thing, there is no unit for K. So please don't write any unit for the K because the dielectric constant has no unit. So here we have to mention only the answer. The K value is 6.5, which is exactly for porcelain. So the K porcelain dielectric value is 6.5. That's it. Thank you.